As you know, in our solar system, planets turn around the Sun in almost circular orbit. But this is the case only if you take the frame of reference of the Sun. But what is the frame of reference?
In Einsteinian relativity, reference frames are used to specify the relationship between a moving observer and the phenomenon under observation. For instance, if you take the frame of reference of a person who is standing in a train which is moving, this person will see an external tree moving, but not a train. On the other hand, if you take the frame of reference of a person who is standing next to the tree, that is to say in the terrestrial reference frame, the train will be moving, but the tree will stay at its place.
That leads us to the retrograde motion of Mars. In fact, this phenomenon can also be applied to the trajectories of planets. We have made some videos with the software Stellarium to show it to you. If you were on the Sun, this is how you would see the planet Mars moving. But that is not really interesting. No, what do you think of that? No, slower.
This is how you would see Mars moving if you were on Earth, watching Mars from March to August 2016. Impressive, isn't it? The same thing would occur if you were on Jupiter. We have modeled this trajectory with lattice probe so that you can see this train trajectory better. Now read the graph if you prefer. To understand this phenomenon, we will take a simulation made by NASA. You can see that the loop made by Mars when you are on Earth is due to the distance between the two planets. So, why is the retrograde motion of Mars so famous?
For a long time, skywatchers have seen this phenomenon, but they were wondering why Mars would stop and then move backward. Especially that, at the beginning, they thought that planets orbited around Earth and not around Sun. But today, as you verified with us, Mars does not stop. This is just illusion.